All right, section 2.4. Today we're taking a look at surveys and cardinal numbers. And we're going to start with what is called the cardinal number formula. So the cardinal number formula says the following, and I'm going to show you a picture of what this is representing in a moment. It says that the number of items, or the cardinality, of A union B is the number of items in A plus the number of items in B minus the number of items in A intersect B. I want to show you why that actually, it feels like it's not quite right. It feels almost like we should be adding these three things together, but I want to show you from a picture why that's not the case. So if we're counting the number of items in set A, it's all of this yellow. Ignore the fact that I bled over the line a little bit, but it's all of this, right? These are the number of items in A. And then if I count the number of items in B, it's this red. And do you see what happened in the middle? It overlapped. It got counted twice, right? So we have to remove the overlap. That's why it's subtracting off the intersection at the end. It's because we counted it twice. So we're going to use, now when you're given the picture, there may not be a need to use it directly, but we'll see an application of where this is useful in a second. As we're taking a look at this chapter, this section of the chapter, we're shifting gears a little bit what we were doing at the end of class last time. What we're doing at the end of class last time is shading the diagrams, kind of like I just shaded this diagram, right? But we were using them sort of like as an image of space, kind of like I've already drawn this one. There's all this space that's yellow, and then there's all this space that's red, and this space in the middle got counted twice. What we're doing in this section is we're actually representing, and we'll get to the application part toward the end, of these are objects, as in the number of objects in each individual space. So over here in A, there are 3 objects over here. In the middle, in the intersection, there are 6 objects. And over here on the right on B are 2 objects. Okay? So these numbers don't represent sort of like the locations or the spaces. They're representing a number of elements within that category. Right? So maybe like this outside category over here I don't have a good example off the top of my head. Let's see if I can come up with something. We could do this. Let's say that we had a class, and in our class we had people from different majors. And so over here on the left-hand side, we had 1 major, okay? Let's just say there was only 2 majors. And on the right-hand side, section B, we had a different major in the middle of people that were majoring in both, okay? So it's the number of people or the number of elements in each of those categories. All right, so what we're looking at on this is just the number or numbers that are represented in each of those spaces. So on part A, it wants to know the number, or it wants to know, hang on, let me read the directions. Use the numerals representing cardinalities in the Venn diagram to give the cardinality, that is the number, of each of the specified set. So on the first one, A intersect B. So what do you see inside of the A intersect B location? There's a 6. So this is 6. So what we've actually found, if you want to be really specific, is that the number of items in A intersect B is 6. Feel free to write that or not to write it, but it's 6. A union B. Now, yes, we have this formula on the top, but it doesn't set up very nicely for my picture. My picture is really straightforward. If you want the union, what pieces are in the union in terms of the numbers you see here? Be bold. Somebody tell me. What do you see?
3, 6, and 2.
3, 6, and 2. So this is 3 plus 6 plus 2, which would be 11. And the reason I can simply add them up, whereas the first formula on there had some subtraction, is because it's isolated the number in each of these individual spaces already, right? If you really wanted to count it, the number of items in set B is 9, the 3 and the 6. The number of items, set A is what I meant to say. The number of items in set B is 6 and 2, which is 8. So we could add 9 plus 8 and then remove 6, and we'd still get 11. But that'd be a sort of weird way to go about doing this particular problem when it's already drawn in this isolated format, right? So we can simply add them from where they are. The next 3 actually, all have some prime notations. Now, we want to be careful All right, so when we're looking at these prime notations, we want to make sure that we understand what it's being described. This says that it's not in A, and this one says that it's in B. So what do you see in this diagram that is not in A and it's in B?
7 and 2.
Just the 2, I think. So the not in A means that I would not include the 3 and the 6, right? So we're looking at the 2 or the 7, but it has to be in B as well. So it will be just the 2 on this one. Does that make sense? Okay, with two of them on the picture instead of like three pictures, 3 circles, we can reason through this pretty okay. So we can do it the next one, same idea. Now we want to do that it is in A, but it's not in B. Okay, so looking at the diagram, what is in A, but it's not in B? That'd be the 3. And the last one says that it's not in A and it's not in B. And what would that be? 7. That's my 7. Okay, does that make sense? I'd much rather you jot down some phrasing kind of like I did in yellow here to help you out if you need it, than to just think, I can do that without doing it and then make a mistake. This is one of those places where I can't see and really do much about partial credit, right? You're just putting in a number, and I don't know where you're getting the number for sure. So be careful when you're working on these. All right, this one's kind of fun because it actually tells you make use of an appropriate formula, and we've only had one formula. Yeah, so that's pretty handy. Make use of an appropriate formula to answer the question asked. It wants us to find the number of items in A union B if the number of items in A is 8, the number of items in B is 14, and the number of items in the intersection is 5. So the formula that we had on the last slide, very first thing, was that the number of items in A union B is the number of items in A plus the number of items in B minus the number of items in the intersection. Now, this particular problem is very friendly because it gives us the 3 values of the things that are on the right. But the reality is it could give us any of those 3 and we could find the 4th one, right? Like they could tell us the number of items in the intersection, the number of items in the union, and the number of items in B, and we could figure out how many items are in A. You just need 3 of any of the 4. So if we have this formula set up, then we're able to put the values into those locations. So this one says the number of items in set A is 8. That doesn't mean A is 8. It means N of A is 8. So all of that gets taken away at the same time, and the 8 replaces it. The number of items in B, again, all of this is 14. And the number of items in the intersection, all of this is 5. And that will allow us to find the union. So what is 8 plus 14 minus 5? 17. Any questions on that? Okay. So the next problem has a lot of details given to us. And it's leading up to the ones after it where we actually put some context with them so you can see how these can be used. So this one says to draw an appropriate Venn diagram and use the information given to fill in the number of elements in each region. So we did Venn diagrams last time. They're those rectangle shapes, right? And we have some circles inside. We have to decide at the beginning of the problem how many different circles we need to draw. How many is it for this one?
3.
It's 3. How do you know?
Because we have A, B, and C.
Right. It describes A, B, and C. And we will label the U out here. Okay, so this is another place where when you do this inside of my math lab, what will happen is it'll have you like drop in a number in each one of these spaces here in a minute. It's going to have you put in a number. It's either going to count you right or you're going to be counted wrong. So be careful, because a small error will potentially make several of the different regions wrong, even though maybe you only made the error at the very first step along the way and you get the entire problem counted off. So be careful. Now, I would like for you to take a look. The first piece, 3 pieces of information given are less than helpful. I'm just going to look at the first one. This one tells us that the entire circle A has 24 items in it. The problem is that the entire circle A has 4 different places where those numbers that add up to 24 could go. I don't know about you. I don't want to do trial and error with the number 24 in 4 different locations and all the options that I could do. And in fact, it's not necessary. And the same is true for the number of items in B and the number of items in C. These are not good places to start working, but they're often the first things that are told to you. So what we're going to do is we're going to bypass all of them, and we're going to look at the second list. So I'm going to skip all of these, and I'm going to move on to this list. Okay, second list. Now, the first one, again, we'll just look at the first one, says the number of items in A intersect B. Okay, so A intersect B would be this football shape right here. And there's not 4 different numbers that I have to put in there. There's just 2. But I still have a lot of options to get to 10, right? I can do 0 and 10 or 10 and 0, 1 and 9 or 9 and 1, 8 and 2 or 2 and 8. I don't want to do that, and neither do you. So again, this is not a good place to start. So we won't start there. So we're going to skip, let me do it this way for now, this whole line. We're going to skip it because every single one of those has that same problem. It's talking about 2 different regions. But do you see what happens when we get to line 3? It's line 3 on my screen anyway. It's actually a really good place to start. So this one right here, what does this mean? N of A intersect B intersect C. It's the one in the very center. Now, it isn't always going to be given to you that way, right? They could give it to you in a slightly different way. But on this one, that's really straightforward. The intersection of all 3 sets is right here in the very middle, and there's only one thing there, one space. And so that tells us that there's a 6 that's going to go in right there. And we're going to build off of that 6 for everything else, okay? So I haven't mentioned it, but this N of U right here at the end means all the numbers that the entire diagram adds up to. So we're definitely not going to be working with that until the very end, okay? So we're going to ignore that for now. But if we go up a line and we actually look at those places where it had 2 values before, like the first one here where it said 10, A intersect B is 10. The A intersect B was right here, right? Those 2 regions have to add up to 10, but now I know what the other one has to be. What does it have to be? Well, it has to be a 4. Okay? There's no trial and error. We're just logically working our way through, and this is where I feel like this feels like Sudoku, if you've ever played it before, right? So you're looking to figure out what does it have to be in the right spot, because guessing doesn't really help you that much. It's very difficult when you guess. So this one's a 4. And we can move to the one right next to it, B intersect C, which is 8. So B intersect C would be this space. So I have a 6 already, and if these 2 have to be 8 together, what's left for this spot? It's 2. So I have a 2 here. And then the last one, A intersect C, is 15. So A intersect C is down here. So these 2 have to add to 15. So if this one's 6, then the other one is 9. So I've got a 9 here. Okay, everybody good so far? So it isn't always like you're working from the inside out, but you are working from one location where you can spread the diagram out and find other pieces based on that. That is how it will work. So we can go back up to the line 1 now, the first line that we skipped. This one says the number of items in circle A, all of it, is 24. So that means this entire circle is 24. Well, I don't know what it is, but we can figure out how much we've already got accounted for, right? We've got a 9, a 6, and a 4. How many are already there? 19. So how many remain? 5. So there will be a 5 out here. Okay, how are you feeling? Feeling okay? All right, moving to the next one then. N of B. Entire circle B happens to also be 24. That doesn't always happen, but that circle is 24. How many do I already have accounted for inside of circle B? There are 12, so how many do I need more outside part of B? 12 more. And then the last piece that's inside of a circle is the 26 for C. So this whole thing here has to be 26. How many is here already? 17. And if I need to get to 26, how many more? 9. Good. There's 9. Okay. There's still a space on the outside that has to be filled in, and it will be really obvious when you're doing my math lab because there will be like these blank spots. I think they're even colored in a kind of an ivory kind of color where it tells you get to fill them in. So you'll know you haven't finished it. But this space out here must be found by what remains, which is the N of U is 50, but that doesn't mean the outside's 50. N of U means the number of items in the entire rectangle because that's the universal set. We already have a lot of them accounted for. So somebody grab a calculator, add them in your head, whatever you wish. How many are accounted for with all the numbers that are there so far?
47.
Yeah, it is 47. And it's supposed to be 50 total, so we're lacking 3. So there will be a 3 on the outside. Okay. So this problem feels just puzzle-y like. I don't know if you like puzzles or not. Some people do and some people don't. I kind of do. So even if there were no application, I would think this is pretty cool. But some of you are like, no, that's not cool. That's just work. And that's like, what's the point? There is a point. So let's look at the last 2 problems, or the next 2 problems anyway, that talk about this. So we're going to use Venn diagrams to answer some actual application problems. We have Joe Long, and Joe Long writes and produces albums for musicians. Last year, he worked on 10 such projects. He wrote and produced 2. He wrote 5. He produced 7. And then we've got these follow-up questions that we're going to answer over here. How many did he write but not produce? How many did he produce but not write? How many did he neither write nor produce? Now, on this one, you might be able to answer these questions without a Venn diagram because it's not a very complicated one. But take a look at where we're headed over here. There's a lot more details here, right? And answering these questions without actually setting up the Venn diagram might not even be possible for you or for me. So I'd like to show you how to do what the directions say, which is to do the Venn diagram in order to answer these questions with confidence. So we do have a Venn diagram. How many circles are going to be in this Venn diagram? How many?
3.
I don't think there's 3 on this one.
2.
This one has 2. Can you figure out what they have to be? RJ?
The amount he produced and the amount he wrote.
Okay, so the 2 circles are the 2 categories of things that are described, which is that he's writing some of these projects and then he's producing some of them. So as we draw our Venn diagram, you're welcome to not use like A's and B's and so forth, but actually write what they are. These are the ones he writes and these are the ones he produces. And this is still the universal set on the outside, so I'm still going to put a U out there. Okay, so again, like over here, there are pieces of this that are harder to work with than others. We want to find the one that narrowly defines or describes one place on the diagram. So what on here actually describes one very specific location on our diagram? Yep, the wrote and produced, which happens to be the first one listed, right? It says he wrote and produced. And means both have to be happening. Where will that 2 go? In the middle. Because the middle part is in the wrote circle and it's in the produced circle.
Intersection.
Yep, in the intersection, exactly. Okay, so we've taken care of that first line. Let's take a look at what else remains. The second one says he wrote a total of 5. So I need to have 5 in which circle? The wrote circle. But there's something already there. How many are already there? 2. So I'm not going to put a 5 out here because if I did, then the 5 and the 2 would make a 7 total, right? Okay, those are common mistakes I'm trying to hit on so that you try and remember when you get there. This is not a 5 in the outside part. What's going to go in the outside part? 3. Because what we want is the entire circle to add to 5, right? Good. So we've gotten that one done. And then it says he produced a total of 7. So my produced circle now, over here needs to be 7, which means what goes out here? 5. Okay, so right now there is no number on the outside. How can we find out what's supposed to go out there? Yeah, so up here at the top, so let me mark this one off that we did this. Up here at the top, it told us that there were 10 projects he worked on, right? So this entire rectangle and everything inside of it needs to be a total of 10. How many's in our diagram so far?
2.
There's actually 10 already there. So what does that tell you that the outside rectangle has to be? It's 0. So there is a number there. It is 0. It's important to realize that there's, of course, the ability to have 0. 0 is fine. But it can't have negative numbers, right? So if you find yourself getting a negative number somewhere, backtrack. You've gotten off somewhere. You probably did something like this. You put the 5 out here where you should have put the 3. You forgot that you had to add a circle up or something like that. That's usually what happens when those negative numbers start showing up, is that you've forgotten that step. Once you have this diagram done, the answers, come very easily from the diagram. So using this diagram, how many projects did he write and not produce? 3. How many did he produce and not write? 5. And how many did he neither write nor produce? 0. So answering the questions is usually the very straightforward part. It's creating the diagram where the work lies. Okay? Okay, this one is very college appropriate. Most people have some kind of financial aid, some kind of scholarship or some kind of a grant, some kind of loans, such like that, when they go to college. And so here's a scenario describing such an event. At the University of Louisiana, half of the 48 math majors are receiving federal financial aid as follows. 5 had Pell Grants, 14 were in college work study, 4 had TOPS scholarships, 2 had TOPS scholarships and were in work study, and those with Pell Grants had no other financial aid. Because these are all the categories of things. I'm going to be flipping back and forth between my slides because I don't have enough space here to draw it like I did on the last one. But hopefully if you've printed yours out, you can see all of it at the same time. So we're going to draw a Venn diagram so that we ultimately can answer these questions. How many had no financial aid, no federal aid? How many had more than one type of federal aid? How many had federal aid other than these? And then how many had top scholarships or work study, okay? So these are where we're leading to after our Venn diagram is drawn. How many circles does this Venn diagram need to have? It is 3. There are 3 different categories of things being described. So tell me what they are.
Pell Grant, college work study, and top scholarships.
Okay. And you can put them on there in any order. That's the order she read them out to me, so that's the order to put them in. Okay? So we got Pell Grants, work study, and top scholarships. All right, so taking a look over here, where will we be able to start? Intersection between TOPS, where was it? TOPS and work study. This one right here is where you're going to start. So the TOPS and the work study should intersect in 2, and that would be right here. So if I do that, I've got 2 regions that I have to figure out where to put the number 2 in, right? Do I do 2 and 0, 0 and 2, or 1 and 1? Okay, so maybe we start at a different place.
Pell Grants, those with Pell Grants have no other financial aid.
This is really different than the last one, right? It tells us that the Pell Grant people had no other financial aid. What is that telling me in terms of this diagram? There's a bunch of zeros, right? There's zeros everywhere that Pell Grants overlap with the work study and the TOPS. Okay, so what that really means is the diagram could have been drawn differently. I could have taken that Pell Grant circle and have it completely disengaged from the others. But I can also just put zeros in them. And those are 2 choices here. I've already got zeros in them, so I'm going to keep going with what I have. But that allows me, Polly, to come back over here and to use the one you mentioned, right? It said 2 had top scholarships and were in work study. So I can come back over here next And I can actually put that 2 in this region, right? Now, that's not the only place it could have gone next, but you had mentioned it, so we'll go there next. What else do you see? Okay, we can do Pell Grants. Pell Grants has 5, and there's only one place to put that 5 left, right? Because there's zeros everywhere else. That's a good spot. What else would you like to do next? 14 in college work study. Okay, so we can go down the list. 14 college work study. So the college work study circle has 0, 0, 2, and it needs to be 14. So I need how many more? 12. All right. The last one on this sort of bulleted list is that 4 had TOPS scholarships. So my TOPS scholarships circle has got 2 in it right now, and it needs to have 4, so I need an additional 2. Now, I don't have anything in the rectangle on the outside yet. How many are supposed to go in this whole diagram?
24.
Careful. 24. Why is it 24, not 48? Ooh. So it said half of the 48 have this category of kinds of scholarships or federal aid, or aid, I should say. So what other kind of aid might they have? Well, they might have scholarships from the university. Most of you probably do, athletic, academic, or otherwise. They might have some kind of scholarshiping money, from a company where they applied for a company scholarship. They might have state financial aid of some sort. Like if you're on Oklahoma Promise, that's something that Oklahoma does. It has state financial aid. So there might be some other kind of financial aid to have. They just don't have federal. Make sense? Okay, so our entire rectangle diagram has to add up to 24. What does it add up to right now? 21. So how many are remaining? 3 out here. All right, ready to answer some questions? Lovely. How many had no federal aid? 24. That's the weird one. And that's why I put it in here, is because I want you to think about it. These are the 24 people that we didn't put in the diagram to start with, right? The ones who probably have some other kind of aid, but not federal aid. There's 24. How many of these have more than one form of aid? 2. Now, in general, what that would need for us, what that would entail us to do is to add up all 3 of those and the 2, right? There's just a lot of zeros here. So if you wanted more than one form of aid, it would actually be everywhere they overlapped. And in our circle here, that's just 2. How many? The 3 on the outside is people who have federal aid, but not one of these kinds.
So we don't know if they, but what
Right.
if more than one of these?
Yeah, it says
Okay,
these
that
forms
makes
of aid. Yeah, this is kind of a fuzzy one because you have to just be paying careful attention to the wording, but yeah. C answers the question you're looking at, though. How many have federal aid other than these forms? That's my 3 that are on the rectangle on the outside. And how many have a TOPS scholarship or work study? 16. Why is it 16 and not 14? It is 16. It says or. Yeah, so or means that we get either or both. So we get the part that's in work study only, the part where they overlap, and the part that's in the TOPS scholarship only. So I'm going to write that in so that when you look back at it later, you'll remember, hopefully, that that's where those came from. It is 16 that had one of those types, so the either or. So when you do these problems, if my math lab fusses at you and tells you you have things wrong, it means you have to backtrack, because if you make one mistake in one place, you're probably going to make more than one mistake, right? Because the problem builds on itself. So take caution.